If there's one mechanic in video games that I enjoy more than any other, that's building. Seriously, I have probably spent more time building and decorating houses in Terraria than playing any other game. And now that I am a game developer and I am creating my own indie game, of course I could not miss the opportunity to create my own building system. Little did I know that this would be the most difficult task I have ever had to tackle. There is a long list of video games that have building systems, and these systems come in all colors and sizes, but from my point of view, there are three main types of building systems: flat structure building, block by block building, and building using modular pieces. Of these three options, building complete structures doesn't sound like much fun, and developing a system to build block by block sounds kind of complicated, so we're doing modular building, baby. Modular building requires modular pieces, so before I started coding anything, I spent some time in Blender trying to decide what kind of structural pieces and what sizes to use, and I ended up deciding on a set of 3 sizes for each piece: 2, 1.5 meters, or if you are from the US, these ones. You guys will use anything but the metric system. I got to work and started by creating the system to place structures in the world. Pretty simple considering that I had already developed a similar system in the last devlog when I added the ability to plant trees. This time, however, I properly set up the conditions to limit where you can build, so you can't build in the air or inside other objects, and I also added this kind of red-green ghost effect to provide some visual feedback. Pretty cool, right? Okay, so like this right here, this is the only easy part of this system, okay? From here it is all downhill. I then got to work on the snapping system, which is extremely important and can single-handedly destroy the entire player experience if poorly implemented. Seriously, I can't put into words how frustrating it is when you want to place a structure and the stupid game won't let you do it in any possible way. Looking around, there seems to be 2 main ways to do this. The first one is using sockets and doing a distance check to get the closest socket, and the second one is using collision boxes and checking which box is being hit to get its position. The first method sounds good, but it doesn't sound too reliable, which is why I decided to go for the second option. I added the collisions, coded the snapping functionality, and after testing that everything worked fine, I expanded it a bit by adding the ability to rotate the structures both freely and at fixed angles when you are in snapping mode. This caused me more work than it should have, but I guess that's a result of not finished Freya's vector math course when I should have done it. Sorry, Freya. This is where the first problem with the building system came up. You see, for this snapping feature, each structure has to have a collision for every other type of structure that can be attached to it in each of the positions it can be attached to. For example, a 2x2 meter floor has 4 collisions for big floors, 8 for small floors, another 12 for walls, 4 more for pillars. You see where I am going, right? And having all these structures with all their collisions active in the game at runtime cannot be good for performance. To mitigate this, the first thing that came to my mind was instance static meshes. In the end, this problem is very similar to the one I had before with the shoppable trees, and if you saw this devlog, you will remember that I solved the problem of having many actors on screen by converting the 3 actors into instance static meshes depending on the distance from the character. So I started to integrate the structures of the building system with the actor to instance converter system, and it didn't work. My implementation of the conversion system was pretty bad, and it depended on me adding each type of asset that must be converted manually multiple times during multiple blueprints. A huge mess. Now it's working, and after a not so easy integration with the building system, only the structures that are closer to the player are actors with collisions, so your PCs are safe. For now. With the building part ready, it was time to add destruction to the mix, just in case something doesn't look the way we like it. Destroying stuff in Unreal is as easy as plugging in this node, but there is a small problem. I can't allow players to destroy everything because, in some cases, parts of the structure can be left in the air. And I mean, this might look fine in games like Minecraft or Terraria, where the building system is block by block, but in games with my kind of building, it doesn't feel right. Actually, I'm not sure what other video games with modular building do in these situations, so time to do some research. Yeah, I'm gonna need a bit more time for this. Yeah, no, this is a very important part of the research. Oh, come on, yeah. I guess I got a little carried away. After carefully testing a few games and filtering the results through a very serious selection process, the destruction system that I like the most is the one from Valheim, so that's the one we're going to be shamelessly joinking. Valheim structures have some kind of stability system that not only destroys structures that are disconnected in the air, but also destroys structures that should not be standing due to their poor stability. I'm telling you, destroying in this game is one of the most satisfying things that you will ever see in video games. So, how are you going to do this stability system? Okay, so I have been brainstorming for a while and I think I have an idea. Let's say this is a wall made up of different smaller wall pieces. The pieces that are connected to the ground have a value of 1, and from there we can calculate the value of the other pieces depending on how far they are from the base pieces. If any piece has no direct connection to the ground, then it gets assigned the value of 0 and it is destroyed. In order for this to work, it is necessary to calculate the stability of the whole structure every time a piece is added or removed, for which it is necessary to find all the pieces that are connected, determine which of them qualify as a base and calculate the stability from there. I'm not gonna lie, at the time I felt very proud to find this solution by myself. Well, it turns out that this is already a thing. It's called graph traversal algorithms, and there are a few ways of traversing a graph, and I didn't know anything because apparently I am dumb, and I spent like 2 whole weeks trying to solve a problem that already had a solution, and now anyway, I coded my algorithm and to my surprise it works great. It calculates correctly the value of all the pieces both when new structures are added and when they are removed. Oh wait, what's happening? Why is it freezing? It turns out that all this chain of actions of finding the neighbors and calculating the stability for every structure is too much for the PC. When there are about 25 pieces connected, the operation becomes so heavy that the game has to stop and wait until this function finishes to be able to continue the normal flow of actions. This happens because in Unreal all the gameplay logic runs in the game thread, and therefore, being a single thread, it has to finish all the operations in order, which makes the game freeze when it reaches this big ass function. The obvious solution is to open another thread and move all the heavy calculations there, so the game can continue to perform the other operations. But the thing is that implementing multi-threading in Unreal can only be done in C++, and honestly I don't know anything about C++. It is too complicated for me, man. Yeah, I don't think this stability system is going to happen.
諦めんなよ。諦めんなお前。どうしてそこでやめるんだ、そこで。もう少し頑張ってみろよ。ダメダメダメダメ、諦めたら。周りのこと思えよ。応援してる人たちのこと思ってみろって。あともうちょっとのところなんだから。絶対やってみろ。必ず目標達成できる。だからこそ。ネバギブアップ。なるほど。こうやって引きずり出してみれば、これがてめえのスタンドか。緑色で筋があってまるで光ったメロンだな。額に指の跡がくっきり浮き出てるさ。貴様の頭も潰れるようだ。佳境い。
After a hard month of work learning the language, migrating the system from blueprints to C++ and learning to work with multiple threads, the stability system is finally functional. No matter how many structures are connected, the game keeps running with a stable frame rate while the calculations are done in the background. I still have to make the stability update little by little instead of all at once to make it look more organic, but that should be easy. The only things missing will be to create the models and materials for the structures, connect everything to the inventory system so that building consumes resources, create the UI and add some quality of life features, but honestly, I am too tired to keep working on this system and we have much more important things to do. If you like what I do, consider supporting me on Patreon and joining my Discord server, and if you want to see me suffer a bit more, check these videos over here. Bye!